Okay, let's solve some inequalities with GDC. Here we have graph of f of x and g of x. And we want to know when f of x is greater than g of x. So f of x and g of x are y values, right? It's the output. So that means you can look at the graph and figure out which one's above the other. So because we want f of x to be greater than g of x, we are looking for when f of x is vertically above g of x. So let's find out where they are the same. Where is f of x equal to g of x? It's right here at -1, -0.5. Here, 1.5 and -2. And here, 4 and -3.5. So those are good places to look at because f of x is equal to g of x, right? Then, because we want f of x to be greater than g of x, we are looking for intervals where f of x is above g of x. How about -∞ to -1? Is f of x above g of x? Yes, because f of x is over here and g of x is down there. How about from -1 to 1.5? Well, f of x is below g of x. So from -1 to 1.5, f of x is less than g of x, and that's not what we want. From here, 1.5 to 4, f of x is above g of x, and that is what we want because f of x is greater than g of x. So if we were to find the solution for x, it would be x is less than -1, or x is between 1.5 and 4. You can write the same answer in interval notation from -∞ to -1 union 1.5 to 4. And the endpoints are not included because it's strictly greater than. If it were greater than or equal to, then all of these endpoints will be included. Okay, when we were solving this, 5x plus 1 over x plus 4 equals 4, then you can do this by graphing, right? So let's do it by graphing. So here's a graph of 5x plus 1 over x plus 4, and this horizontal line is y equals 4. And if we were looking for the place where these two are equal to each other, then it'll be right here. So let's find the intersection. Press second trace 5, enter, 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 and you get 15 and 4. So the coordinate here is 15, comma 4. And the x value is what we really care about in the solution, right? And I also know from looking at the denominator here, the vertical asymptote is at x equals 4, or -4. Okay, so what if I wanted to know when is 5x plus 1 over x plus 4 greater than 4? That means the reciprocal curve here, one that goes up here and one that goes down here, that has to be above the horizontal line. And when does it happen? From -∞ to -4, that'll happen, not including 4. And then after you pass 15, right? When x is greater than 15. So that will be from -∞ to 4, at -4, and that's a union 15 to +∞. And if you wanted to not use interval notation, you can write x is less than -4 or x is greater than 15, because that's those are the intervals when 5x plus 1 over x plus 4 is greater than 4. If it's the opposite, if you wanted to know when is 5x plus 1 over x plus 4 less than 4, then you have to find out where in this domain the the curve is below the straight line y equals 4. And it happens right there. And that's the only place. And that would be from -4 to 15. Again, not including the endpoints. Here we have very different question. This is going to be a straight line and this is going to be a quadratic. But we still want to know how to solve this inequality. You are not going to see this question on the test, but the process is very similar, so I'm going to go through this. Whenever you have something like this, whether you solve the equality or inequality, you're going to put one side in y1 and the other side in y2. So I'm going to do that over here, and I'll go 2 minus 3x. In y2, I'll put -6x squared minus 20x. And then I'm going to graph it. Okay, something's not right, so I am going to change my window setting. I'll go to zoom 6 and see if it's not really. So I'm going to change the y maximum to 25. Hopefully that'll do, and it does. Okay, so this is my graph. Now, I am looking for when the quadratic is bigger than or equal to the straight line, and that happens over here, right? So I need to know the coordinates of this and here. So I'm going to find that here. Second, trace 5, enter, enter, enter. This one over here is -0.123, 2.37, and second, trace 5, enter, enter, 5. And the second one is -2.71, 10.1. Okay, 236 fig. Because the interval I'm looking for is right here, I'm going to write -2.71 less than or equal to x less than or equal to -0.123. And the endpoints in this case are included because here it's less than or equal to. Let's do a couple more examples quickly. Okay, it says solve. I'm going to put left side in y1, right side in y2. Okay. Second, alpha y equals enter, and I can put fractions in. It'll be x plus 1. In y2, I'm going to type in 2, and I'm going to graph it. Okay, I'll do zoom 6. There. And there's my graph. All right, now, here, the vertical asymptote is going to be x equals -1. And I need to know this intersection, and let's find that. Second, trace 5, enter, 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 and that will be 0.5, 2. All right, when is 2 greater than or equal to the function? So we want the straight line to be above the curve. That's going to be here, right? Anything bigger than 0.5, and anything to the left of -1. So you can write x is less than or equal, no, not equal to, x is less than -1, and x is greater than or equal to 0.5. Now, you might be wondering, okay, why is this one over here is less than or equal to? Why is this one less than, but this one is greater than or equal to? You are not being consistent. Well, first, let's think about the domain of this function. The domain of this is x is not equal to -1. So x equals -1 is not in this domain. That can be part of our answer. Also, you can see from the graph that x equals -1 is our vertical asymptote. That means this graph is never going to touch -1, so it shouldn't be equal to -1. Over here, they intersect. At x equals 0.5, the two sides are actually equal to each other, so that point counts. Okay, last question. This one we did in class, we'll do it again. So we type in the function 2x minus 4 over x minus 1, and the right side is 1. Okay, graph it. Here is our graph. Okay, we need to know a couple of things. First, where is the vertical asymptote? Vertical asymptote is at x equals 1. Okay, and then it meets here. Let's find that intersection. Second trace 5, enter, enter, enter. And it says, oh, no sign change. Let's go back. Second trace 5, enter, enter, and then maybe 3. 3 and 1. 3, 1. Okay, so I know all the important information and I can answer this question. Okay, when is the curve below 1? Over here, the curve is down here, and then the straight line, y equals 1, is down here. That's not good. Here, from 1 all the way to 3, the straight line is above the curve, right? So that's what we're looking for. From 1, x, 3. In this case, neither of those points are included because you want to know when 2x minus 4 over x minus 1 is less than 1. Okay, so at x equals 3, these are actually equal to each other, so that point shouldn't count. And x equals 1 is a vertical asymptote, that shouldn't count anyway. Okay?